Boom!
Uy, ginalaw. Sorry. Kasi ginalaw yung mesa ulit. Sorry.
Boom! Boom!
Hi everyone! We are in Group 2 from STEM 1113.
And we are here today to teach you the different types of testing on stats and prompts. So, enjoy! Yay!
The first problem is all about central limit theorem.
This is the first example.
Based on the given, we can see that the mean is equals to 1039 ounces and standard deviation of 69 ounces and the random sample of 1039 ounces. We apply this formula of z equals to x minus m over standard deviation and we'll get 0.50%. Now with the normal curve, we graph the answers, place the z results and shade it. The shaded part will be rejected region 1 and the clear is non-rejected region. That the mean is 42.5 and the standard deviation is 13.6. They're saying that 25 fishes will have sample mean of 40. So we're interested in the probability that x will be less than 40 in this particular problem. First, we'll do the standard deviation, finding the sample of it. Now, we can use our z-score. So now we'll focus on the curve. Our mean is placed at the center P. Look up on the z-table and it's done.
given problem. A mean of 136 milliliters, standard deviation of 70 milliliters, sample mean of 149, and sample size of 70. Following the formula of the central limit theorem, we get the answer 0.36, which is equals to 64.06%. Sample mean should be less than probability, so we conclude that this shaded region should be less than 0.36.
The following problem is all about z-test.
This is the first example.
First problem on z-test. Mean of 40, x of 38, standard deviation of 10, alpha level of 0.05, and total population of 33. Step 1 is stating our hypothesis, wherein we have HO the null, HA is the alternative. HO will have M, our mean is equal to 40, and for the HA the inverse of it not equal, so M is not equal to 40. Step 2, the level of significance. We have our alpha of 0.05, and we classify this as two-tailed because of the equal and not equal symbol that we use. Step 3, critical z value from our z table. We have 1.91, positive and negative because it is two-tailed. Step 4, computing, and we are gonna use this formula of z wherein it is mean minus sample mean over standard deviation over square root of n, and we'll just replace the given variable from earlier and calculate into our calculator, and we'll have the answer of negative 1.14. Step 5, where we illustrate or graph with the use of the normal curve, and don't forget to indicate the center as 0, right side of it as the positive part, and the left the negative one. And based from our critical z value, and it is two-tailed, we're gonna use both sides of the graph, the left and the right side of it. Don't forget to shade that region out because that will serve as our rejected region, and also indicate our z value, which is negative 1.14, and I forgot the rejected region or our critical z value is positive and negative 1.91, and the non-shaded part will be the accepted one or the non-rejection zone. And lastly is our step 6. Since we do not reject the HO, we can conclude that the claim is stating the truth, that the company selling time of a residential house is equal to 40 days. So these are the given for the problem 2. Sample mean of 40,400 pesos, mean of 39,950 pesos, and as 40 standard deviation of 4,050. Step 1, where we formulate our hypothesis always write HO and HA. And for z-test, we always use the mean. Mean of HO is less than or equal to 40,000, while HA is mean is greater than 40,000. Step 2 is writing down our level of significance, and it is 0.01, and it is considered as one-tailed. Step 3, we'll have the critical Z value of 2.326. Step 4 is the solving part. Again, with the help of this formula, the z-test formula, we'll just replace the variables, the given variables that we had earlier, to the formula. Standard deviation of 4,050, population of square root of 40, and with that we'll have the result of negative 0.08. Step 5, where we graph with the use of the normal curve. Always indicate the center as 0 and the right side of it as the positive part and the left as the negative. And since our z value is at -1, we'll focus on the left side of the illustration, shade that region out. Our critical z value is -2.326 and our z value as 0.08 negative also, and that will have the non-rejection zone from it. Last step, the step 6, wherein we conclude. And since our age O is accepted and our HO is M is less than or equal 40,000, and our claim is that the mean is much more greater than 40,000, we can now conclude that there is no enough evidence of tricycle drivers earn more than 40,000 per year. Are the given for our last example. Sample mean of 14,300 pesos, total population of 27, sample mean of 12,700 pesos, standard deviation of 6,800, and alpha level of 0.01. Step 1. Okay. Write our HO and HA, the mean, wherein we based our hypothesis. HO is greater or equal 14,300 pesos, and our HA is mean is less than 14,300 pesos. Step 2, our level of significance. It is 0.01, and it is one-tailed because it is greater than or less than. Step 3, our critical z value from our z table, wherein we classified as -2.326. Step 4, the solving part again. Step 4, okay, use the formula again of the z-test, and once again replace all your variables on the formula. Standard of 6,800 all over the total population of 27, square root of it, add that one up into your calculator, and you will have -1.22. Step 5, wherein we illustrate or graph with the use of the normal curve. Indicate the center as 0, right side of it as positive, of course, left negative. And since our critical Z value is negative, we'll focus more on the left side of the illustration. Shade the part where our critical Z value of negative 2.326 occurred. Shade that region out since it will be our rejected region. And don't forget to label our Z value of negative 1.22. And the right side of them will be our non-rejection zone. Step 6, wherein we conclude. Well, since we accept the HO, okay, we can conclude that there is not enough evidence to support the botanist's claim.
You have any idea what is the next topic is all about?
It's all about t-test. And this is the first example.
First one, we have the M as 100, sample of 140, total of 30, and S as our 20. Step 1 is, again, testing the hypothesis. We have HO and HA, and we classified our HA as not equal, and the inverse of it, that will be on HO as equal. So our HO will be not equal to 100 and our HO is 100. Step 2 is the level of significance. Level of significance on this one is 0.05, and our DF were in the formula of n minus 1. 30 minus 1 will be at 29, and this is considered as two-tailed since we use the equal and not equal symbols. Step 5, which is illustrating with the use of the graph. And since our critical T value is positive and negative, will both indicate it on the left and the right side of our illustration. The non-shaded region will be the accepted one, and the shaded part is the rejected region, and indicate our T value of negative 10.95 at the left side. Step 6. Since we reject HO, we therefore conclude that there is enough evidence that the medication significantly increased the intelligence. So these are the given in the second problem. We have M as 68, X 70, N 25, and S as 4. Step 1. Our HO will be M is less than 68, and our HA, the inverse of HO, will have M is greater than or equal 68, and that will be our claim. Step 2, which is stating our significance. It is 0.05 and our DF is 25 minus 1 is equal to 24, and it is classified as one-tailed because of the greater than and less than symbol. Step 3, our critical value, which is positive 1.711. Step 4 is again computing or solving. Use again the formula of the t-test and substitute the given from earlier into the formula. Calculate it and you will have the answer of 2.5. Step 5, illustration. Okay, since our critical z value is at positive, we'll focus more on the right side of the illustration. And since our critical value is 1.17, we'll shade the region that it hurdles. And our z value of 2.5 will be at the rejected region, and the non-rejected one will be the accepted one. Step 6. Since we reject our HO, we can conclude that the probability of selecting a sample size has a mean greater than or equal.
The next problem is all about one proportion z-test. And this is the first problem.
So these are the given on the first problem: x as 53 and 300, p 0.20, population proportion 17.67, and the q, we have this formula of 1 minus p is equal to 0.8 and the level of significance is 0.10. Step 1 is formulating our hypothesis. Our HO will be P is less than or equal 20%, and our HA is P is greater than 20%, and that will be our claim. Step 2 is writing our level of significance, which is 0.10, and it is classified as one-tailed because of the greater and less than symbol. Step 3 is the critical z value, and we have positive 1.282. Step 4 is computing or solving, and we use this formula wherein sample proportion minus population proportion all over square root of PQ over N, and we'll just substitute our variables into this formula and tap that into our calculator, and we'll have the answer of negative 1.01. Step 5 is illustration with the help of the curve. So we state our critical z value of positive 282, which will be on the right side of the illustration, and shade that region, and our z value of negative 1.01, and the shaded area will be the rejected zone. Going back to our hypothesis, we now reject our claim and accept the HO. Lastly is the step 6, wherein we conclude. Since we do not reject the HO, we can conclude that there is not enough evidence to support the flu drugs A and B are comparable to each other. On the second example, example, we have x as 150, n to 50, p 50% or 0.50, 0.6, q 0.5, and level of significance 0.01. Step 1 is formulating the hypothesis. HO will be P is equal to, the inverse of it will be HA. P is not equal to 50%. HO will be P is equal to 50%, which will be our claim. Step 2 is the level of significance. So we have 0.01, and it's gonna be two-tailed since we use the equal and not equal. Step 3, critical z value. Since it is two-tailed, we will use positive, negative. It is positive, negative 2.576. Step 4 is computing or solving, and we're gonna use the formula z is equal to sample proportion minus population proportion over square root of PQ over N, and we'll just replace the given to the formula, and we'll come up to the result of 3.16. Step 5, which is the illustration with the help of the normal curve. Since it is classified as two-tailed and our critical z value is 2.576, we'll both use the side of the illustration, the positive and the negative side, left and right. Okay, we'll both shade it because that's how you do it. And yeah, and we'll indicate our z, the one we compute before, 3.16, and we indicate the shaded region as the reject and the non-shaded part as the non-rejected region. Lastly is the step 6, wherein we conclude. Since we reject the HO, we can conclude that there is not enough evidence to support the claim stating that the new vaccine is effective than the old one.
The last topic is all about two proportion z-test, and this is the first problem. Our first total population is 195 and our second is 605. So our P1 is equals to 0.2103, our P2 is equals to 0.5802, our Q1 is 0.7897, and our Q2 is 0.4198. And our level of significance is 0.05. Step 1. Forming our hypothesis. In step 1, we're going to form our hypothesis for the problem. So we're going to write HO and HA. For HO, we're going to write P1 is equals to P2. And for HA, P1 is not equals to P2. Step 2, we're going to set the level of significance of the problem. Our level of significance of the problem is 0.05, and it is also two-tailed. Step 3, we're going to identify the critical z value from the z table. Since it is two-tailed, we're going to write positive and negative 1.960. So the next step is step 4. In this step, we're going to compute the test value using the given formula of P1 is minus P2 all over square root of P1 times Q1 over N1, and that will be added to P2 times Q2 over N2. And here, we're just gonna replace the given variables into the problem into the formula square root of 0.21 times 0.79 plus 0.58 times 0.42 all over 195 all over 605. And that will give us the result of negative 10.45. So the next step is step 5. In step 5, we will graph our findings to make our decision, and we will use normal curve in order to do that. So in our normal curve, we're going to label its center as 0, and the right side will be positive numbers and the left side will be negative numbers. After doing that, we're going to plot our critical z value that we get at step 3. For the right side of the normal curve, we're going to plot 1.960, and for the left side, we're going to plot negative 1.960, and we're going to shade that region, the both side of it. We also need to label it so that we're going to know where is the critical z value. So here right now, we're going to plot our z value, which is negative 10.45. So the non-shaded region will be the accepted region. So since our negative 10.45 is inside the shaded region, we do not reject the HA. Lastly, for the last step, which is step 6, we're going to conclude for our problem. Since we reject the HO, we cannot conclude that the two drugs are comparable.
We're done!
Dapat siya